Okay, move on to the next question. Test the analysis of variance between entrance test percentage and MBA percentage at significance level of 5. Make decision using hypothesis testing. Okay, so before we go into the code, we need to understand what is hypothesis testing. So I have two assumptions. One is all the groups can have the same MBA percentage. That is my initial assumption. And my alternative assumption is at least one of the group has a different average. That is my H1 assumption. Okay. So let's see, the significance level is 5. So I have declared alpha is 0.005. So first we need to entrance test percentage is a numerical, it's not a categorical column. So first we need to convert the data that we have the 215 records, right? So first we need to convert those records into some groups. So based on the entrance test percentage, so here I have grouped them into low, medium, high, and I have used Python, pandas QCUD function to group them into three different groups. So I have the end group and store it in the entrance test group data frame. And then once I have the data frame, I calculated the MBA average MBA percentage for each of the groups. Okay, so my assumption was H0 assumption was all the test group have the same average. My H1 assumption was at least some difference could be there. So we are doing one way ANOVA testing since we have more number of two more group. So we are doing ANOVA testing. So the output variable we get from ANOVA test is F and P. F is how much difference we have it for the each group. P is a significant test. Okay, whether how much is the chance for that one. Okay, so like we have seen in the previous example. Okay, so the decision is we can accept it or reject it. Okay, so the difference whatever we could see for F is 0.6.785. That means there could be a difference between this group for their MBA percentage. Okay, so and then the initial hypothesis, null hypothesis testing assumption is all groups have a same MBA percentage. So my output is finally I am rejecting it. Okay, since we could see more differences, it's higher than the decision level. I'm rejecting it. To the next code, test the similarity between the degree and specialization with respect to salary at significant level of 5%. Make decision using hypothesis testing. So here we have only two group of people. So ANOVA test is not needed. Only the T test is enough. So since we are going to compare the performance for two different group of people. Okay, let's see. So we need to group them by degree, specialization, science and technology. So I filter the place is the data frame. So if from the data frame I'm just filtering only the records, the science and technology and the marketing and HR. So basically I'm filtering and storing in the value A and B respectively. These are the data frames. So my null hypothesis is average salary of science and technology is equivalent to average salary of marketing and HR. My alternative hypothesis both there could be a difference. Okay, so I'm doing the T test here. So in the T test I am passing A and B and equivalent variable equal to false. What does it mean is like the number of result for the placed and number of result for the non-placed could vary. So I don't want t-test to be affected with because of this variance. So that's what I'm saying. So here the output from the t-test is one is significance value which is p, and t, that t is like how much is the difference between two group performance. Okay, so here we have a limit of alpha, so I'm rejecting it based on that. If the t value is less than alpha, I'm rejecting it. So let's see what we got it. So we have 41 people those are from science and technology. We have 53 people from marketing and HR. Their average salaries are 3 lakh and 2 2 2 lakh, around 2 lakh, 2 lakh 70,000. So I'm the t test value is 2.550, so which is less than the alpha, so I need to reject it. So we can pretty sure that the result is accurate or not by checking the p value, meaning like there could be a slight differences, that's what meaning. So the output is here is I'm rejecting my null hypothesis as h0.